Bonjour, welcome to Wahsa Citizens Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I'm the teacher, Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday from 10 to 11 in the morning, and we are now starting our third week of our 9-week course. At this point, now that we're starting our third week, you should be starting to think about what work you're going to submit for marking. The key questions are all marked with a little key icon and listed at the end of each of your IL lesson. So please do all of these questions to check your understanding questions, activities, and review questions as they are assigned. Explain all of your ideas, your thoughts in complete sentences so I truly understand what it is that you are talking about, and make sure you're actually answering the question opposed to just talking about the topic. You're welcome to do this by hand or electronically. If you want to write in the workbook, you can, it is yours, though the spaces are pretty small, so I'd encourage you not to, just as you can't get full thoughts really there, I wouldn't think. However, if you are doing it electronically, Word and Google Doc files are the ones that are easiest for me to open. Everyone has access to Google Docs through their NNEC email address, and I can help you do that if you need support to figure that out. But if you're going to use a different file type, most likely that is fine. Just let me know so we can make sure that I can actually open your files so that you haven't done a bunch of work that I can't access. So then how do you submit your work for marking? The first method is to scan your work electronically. If you're going to do it by hand, then you can scan your completed work either with the Apple devices have a Notes app, which has a scan function, and the Android devices have a Google Drive app with a scan function. Both are fairly straightforward. If you need to take pictures and send me the pictures, that's okay. Scanning just means that the documents are a little bit smaller, a little bit easier to send and mark, but if you need to do pictures, that's totally fine. I can make it work. Then you can send it to me once you have it electronically to by email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can also send it to me through Facebook Messenger, where my name is B Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street, with a bright red building next to the post office, and we have a small white mailbox next to our side entrance. We are not yet open to the public, hopefully soon, but you can just put your work in the mailbox at any time and I'll get it back to you as soon as I can. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to fax in their work if you have access to a fax machine, that's completely fine. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B Slate Wahsa. If you friend me on Facebook and subscribe to my YouTube channel, then you will get notifications every time I upload one of our lessons. All of our radio Zoom classes are recorded and I post them on YouTube shortly after airing, and I put them in a playlist all called SVN3E. This way, they're fairly easy to find and access, and you can go back to them if you need to. Also, all of the videos that we've watched in class are listed in supplementary videos, all the ones that are connected through YouTube. So you can go there and find videos from their original sources if you would like. Science is really visual. I try to incorporate as many videos, images, graphs, charts as I can to help connect all of our concepts together. So I strongly encourage you to connect to the YouTube videos if you can't join me live. If that isn't possible, then feel free to let me know and I can send you a copy of the recordings so that you still have access to the full experience, even if you don't have reliable internet access. All right, if you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE at nnec.on.ca. Again, you can connect with me through Facebook at bslatewasa. You can call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11 in the morning, so that's not a great time to get a hold of me. I think it's important to position myself within the context of this course, so I do that every lesson. I have white settler ancestry, I have white privilege, and this has shaped the way that I've experienced education as well as how I now teach it as an educator. So I recognize that, and though I cannot erase my white privilege, that is something that is a bigger societal issue that we will most likely not do within my lifetime. I can acknowledge it and work to disrupt the systems of white privilege and white supremacy in order to make education more equitable and accessible for all students. I live in Northwestern Ontario on the traditional territories of the Anishinaabe people and work to honor and learn from this culture and these people in order to integrate their knowledge and perspectives into our course to give a full representation of the wealth of knowledge in my area. I do not have it all figured out. And as an educator, I have lots to learn and unlearn. So this is a process that I continue to work on and hope to do better with every iteration of this course and every lesson. I hope to integrate more and more Indigenous representation, though it is a bit of a process, and I apologize for that. Our textbook is also very Eurocentric. I recognize that a lot of the examples are white communities and based off of white scientists. This is problematic and less than ideal, though I've been looking for other resources and there are not a lot. So I will continue to work on developing course material that integrates Indigenous, Inuit, and Métis knowledge and experiences, as our textbook ignores these people. And there's a wealth of knowledge there that I think that we're really missing. All right, so we're continuing with Unit 2 today, which again is maintaining healthy ecosystems. So remember that healthy ecosystems clean our water, purify our air, maintain our soil, regulate the climate, recycle nutrients, and provide us with food. They provide all the raw materials and resources for medicines and other purposes, and they are the foundation of all of our civilization and sustain our lives. Basically, we need them or we could not survive. So as we have less and less healthy ecosystems, we are having more and more problems. So today's lesson is lesson 6, and we are talking about how human activity affects these ecosystems that we defined in our previous lesson. So our learning goals are such that at the end of this lesson, you'll be able to describe the effects of oil spills and acid precipitation on ecosystems, and you will understand the likelihood and signs of ecosystems recovery in each of these cases. You know you've met the learning goals because you know the impacts of oil spills on aquatic and terrestrial ecosystems. You know the impacts of acid precipitation on aquatic and terrestrial ecosystems, and you can explain how ecosystems can recover from human impacts as well as how likely they are to recover. So we're going to focus on 2 impacts, human activity impacts specifically today. So we're going to be looking at oil spills, and then we're going to be looking at acid precipitation in terms of how our actions have a great impact on both aquatic, so water, and terrestrial land ecosystems. So first, oil spills. So when we think of oil spills, we usually think about oil tankers accidentally spilling oil in marine or aquatic ecosystems, such as saltwater oceans and seas. This is what comes to mind for me. So this is an image of a oil tanker that is sinking and leaching oil all over. All this black stuff is oil into this blue crystal beautiful ocean or sea, and this black guck is from this tanker is spilling into it. That's what my brain thinks of when someone says oil spill. That's what my brain comes to. but oil can be spilled on land as well. Oil that is spilled on land often runs into freshwater ecosystems like lakes, rivers, and wetlands. So here is an image of a land oil spill. So here is this darkened area is where a pipeline or a tanker or something spilled oil, and now it is leaching into the ground and was most likely going to affect this creek along here as well as groundwater um, and all the plants in this area. Also, oil does not always enter aquatic systems accidentally. Ideally, we want to avoid accidents, but we don't want it to be done intentionally either. But oil can enter the environment when a tanker ship tanks are cleaned to remove oil residue from inside tank walls, and this is called bilge washing. So here's an example where uh, inside this water is now being shot out back out into a the water system, and it's rinsing out, it's cleaning out inside of these boats, is cleaning out the oil, the residue of the oil tank, which means that they're just, as you think about like when you're rinsing a bottle, you're rinsing something out in your sink in your kitchen, and you pour water in to rinse it out and you shake it around and then you dump the water out in order to get all of that residue out. That's what's happening here, is that the oil residue is being shot out, is being put into the waterway, and that is intentional. We're doing that on purpose. So what are the impacts on aquatic systems, ecosystems? So we're going to look at, I think, the 7 of the worst oil spills in the world. Your workbook talks about one of them, and we will touch on that one. But these are the worst oil spills that have happened. That I just thought we should give a little bit more information opposed to just the one that in your book, to see the context, because there are other ones, like in when I read your book, I thought this is like the worst because it's what it talks about, but then there are other ones since then or around then that have been significantly more oil spilled into the water. So the first one we're talking about is the Persian Gulf oil spill, and this happened in January of 1991, and it happened in the Persian Gulf in Kuwait. So the amount of oil spilled was about 380 to 520 billion or million gallons, which is approximately 1.4 billion to 2 billion liters. I don't gallons, there's an unit of measurement that I know too well, but I think about liters of milk, that I do know. And so 1.4 billion to 2 billion liters is how much oil was spilled into the Persian Gulf. And it happened over 3 months. So it was a long thing that was happening, that took a long time to recover from. So this is the worst oil spill in history. And it was because it was used as a defense tactic. So in January of 1991, Iraqi forces attempted to prevent American soldiers from landing on their shores by opening valves at an offshore oil terminal and dumping oil from tankers. The oil resulted in a 4-inch thick oil slick, so a layer of 4 inches, which, if you think about, like, 4 inches is like, I don't know, it's about that big. If you think about that, like from this line to this line approximately, is how thick the oil was on top of the water that spread across 4,000 square miles of the Persian Gulf. Oil continued to spill into the Gulf at a rate of 6,000 barrels a day for 3 months. By the end of July, most of it had been removed. Even though wartime conditions hindered cleanup efforts, oil continued to seep into the water from coastal sediments for a year. So this huge amount of oil was poured into the Gulf on purpose in order to prevent American soldiers, as a war tactic, in order for them to prevent them from coming and landing on Iraqi shores. This is what happened. So this is pretty intense in terms of the impact on the environment due to war, conflict, which they're most likely fighting over oil anyway. It's pretty devastating. All right, so the second one is the BP, Deepwater Horizon oil spill. And this happened in April of 2010, so just 12 years ago. And this happened in the Gulf of Mexico. And it spilled about 206 million gallons, which is about 780 million liters. And again, this was over 3 months. So the BP Deepwater Horizon oil spill is officially the largest accidental spill in world history. It began when an oil well a mile below the surface of the Gulf of Mexico blew out, causing an explosion on BP's Deepwater Horizon rig. The explosion killed 11 people. BP made several unsuccessful attempts to plug the well, but oil flowed at a rate as high as 2.5 million gallons a day until the well was capped on July 15th in 2010. Oil gushed from the broken well for more than 85 days, oiled 572 miles of Gulf shoreline, and killed hundreds of birds and marine life. The long-term effects of the oil and the 2 million gallons of dispersant used on this fragile ecosystem remain unknown. But experts say that this could devastate the Gulf Coast for decades to come. So both in terms of the oil and the ways that we attempted to clean it up, those chemicals are going to impact the Gulf Coast for decades and decades. Like, who knows how long it's going to be until this doesn't have an impact. And you just think about how valuable how important we put, or how much value we put on oil. Our whole society are built on fossil fuels, built on oil and gas and things like those fossil fuels in terms of running our world. And then yet this much can be wasted in terms of thinking of the value. Like, it just then is now it's just a pollutant in our world. And then how much big of an impact, like if we weren't doing this, then these accidents wouldn't happen and we wouldn't be having such a negative impact on our environments. It just boggles the mind. Okay, so number 3 is the sorry, I'm bad at pronunciation, one oil spill. And this was June in 1979, and what happened at the Bay of Campeche in Mexico. Sorry, my Spanish pronunciation is awful. So the amount spilled was 140 million gallons, which is about 530 million liters, and this happened over a year. So again, like the BP Deepwater Horizon fiasco, the Itoc 1 oil spill didn't involve a tanker, but rather an offshore oil well. Pemex, a state-owned Mexican petroleum company, was drilling an oil well when a blowout occurred. The oil ignited and the drilling rig collapsed. Oil began gushing out of the well into the Gulf of Mexico at a rate of 10,000 to 30,000 barrels a day for almost an entire year before workers were finally able to cap it. The oil from this spill swept into sandy beaches and into mangroves, coastal lagoons, and rivers. It has had a tremendous impact on marine life, including octopuses, Kemp Riley's turtles, and shrimp. So again, just the vast impact that these oil spills have. Like, accidents happen, totally reasonable accidents happen, but then the incredible detrimental impact that this has on the animal life and the plant life is just devastating. All right, then we're going down to the 14th, which I believe is the Exxon Valdez oil spill, which is what they talk about in your book, I believe. So this happened in March in 1989 in Prince William Sound, Alaska, and it was 11 million gallons, 41.6 million liters, and it happened in one day. So when the Exxon Valdez super tanker hit a reef off the Alaskan coast, 11 of its cargo tanks ruptured, dumping 11 million gallons of crude oil into Prince William Sound. The spill could have been much worse, considering the Valdez was carrying 53 million gallons. Still, it wreaked havoc on the ecosystem. Responders found carcasses of more than 35,000 birds and 1,000 sea otters, which was considered to be a fraction of the animal death toll because carcasses typically sink to the seabeds. It's estimated that 250,000 seabirds, 2,800 sea otters, 300 harbor seals, 250 bald eagles, and up to 22 killer whales died, along with billions of salmon and herring eggs. Oil from the spill remains a few inches below the surface on many of Alaska's beaches. So this is still impacting these areas. And this one is the one that I believe, again, is talked about in your workbook. And this is the 14th worst oil spill that has been documented. So when reading your book and thinking about, wow, this is really bad, and it is totally really bad, but there are 13 other oil spills that are worse than this one. So what are the impacts on the plants of these oil spills? So marine plants like kelp and seagrasses that are found in the area between high and low tides can become coated with oil and die. Oil does not only impede the growth of plants, it creates further damage by leading to algae formation. So sometimes oil and water results into increases in algae, which grows very quickly. So some algae like all the oil, and so then they increase. The widespread algae population in water creates adverse conditions for the growth of other aquatic plants. So that algae takes up space, water, nutrients, sunlight, and then other plants cannot grow and thrive from both the oil and the algae. Then chemicals which are used to treat the oil cause further obstruction in the growth of plants. So even in our attempts to clean up the oil, we are adding other chemicals to the ecosystems, which means that those have an impact and make it harder for the growth of plants. The loss of plant cover impacts other organisms that depend on these plants for food and shelter. So here is one image of plants along the coast of a place where an oil spilled. So this is about 9 months after a spill. You can see some plants are starting to recover, but still it's not doing great. And then 24 months, so 2 years after the oil spill, you can see, yes, there's been some growth, but there's also oil residue still in the soil, still impacting the plant growth, which means that animals and plants, either ones, can thrive and survive in this area. All right, so then what are the impacts on animals? So mammals, birds, and fish can be smothered by the oil, or they can ingest the spill oil and become poisoned and die. So either they can't breathe, or just consuming the oil kills them. Oil also mats down the fur of mammals like sea otters and seals, and the feathers of birds, destroying their insulating abilities. This means they can freeze to death. So again, another way that the oil kills animals. Birds are at an increased risk of drowning because oil damages the structure of the feathers that allows them to float and fly. Oil vapors can be toxic, damaging the nervous systems, liver, and lungs of various animals. Organisms can also be indirectly impacted if they eat contaminated prey or plants, or they may starve if they refuse to eat things that smell and taste like oil. So again, there's just so many ways that that oil impacts these animals. It makes them unable to survive. Then also reproduction is impacted, with birds' eggs being smothered, fish eggs being prevented from hatching, and breeding and nesting grounds being destroyed. So not only is there an impact on current generations of animals, but future generations as well. So there's going to be less of them because they weren't able to survive. So here are a few images that are just heartbreaking in terms of a turtle and a pelican just covered in oil. I can't imagine, and like sledging through trying to survive and get clean. Like, it's just gross. Okay, so then what are the impacts on terrestrial ecosystems? So on land. So pipeline oil spills result in severe damage to terrestrial vegetation, but usually our relatively local areas are affected, except when extremely large spills happen. This is because soil, particularly if it's rich in organic matter, has a great absorptive capacity for petroleum. So the soil is able to absorb the oil back, whereas when it's on oil, we all know oil and water don't mix, and so the oil just spreads. In addition, much of the oil spilled on land tends to accumulate in low spots and does not spread widely. Oil degrading bacteria, fungi, and other microbes in soil rapidly proliferate in response to the presence of hydrocarbons that can be used as a source of metabolic energy. Crude oil behaves as a herbicide to terrestrial vegetation, killing foliage and woody tissue. So bacteria and fungi thrive, but then plants die. Some vegetation does not die immediately after exposure to oil, but can be more vulnerable to physiological stresses associated with harsh winters. So even if they survive the oil spill, they might not have the tools that they need in order to survive general weather. And then lichens and mosses are slow to recover. So how can we think about recovery for ecosystems based on oil spills? So whether or not efforts are made to clean up an oil spill, it could take a long time for an ecosystem to recover. The length of recovery time depends on how many different organisms in the food chain have been affected. It can also depend on how sensitive the environment is. Recovery may take weeks for a bedrock shoreline pounded by waves that break up the oil, or months for an exposed sandy beach. Marshes and salt flats where the oil has been embedded in sediments can take years or even decades to recover. It doesn't matter if we work to clean up these areas. Yes, we should work to clean up these areas. We should take responsibility, but that doesn't just mean that everything is magically okay. All right, so now you should be able to do the key questions on page 46 to check your understanding question 1, which talks about describing the oil spill effects on plants, mammals, and birds. All right, so that's our first human impact that we were talking about today. The second one is acid precipitation. So pure water is considered a neutral substance. It has a pH of 7. Remember the pH scale, which 7 is in the middle. So clean or unpolluted rain is naturally slightly acidic with a pH of 5.6. So already our rain is slightly acidic. But acid rain is any precipitation, so people call it acid rain or acid precipitation, but any precipitation that has a pH lower than 5.6. So typically the pH of acid rain is between 2 and 4.5. Wet deposition is what we most commonly think of as acid rain. The sulfuric and nitric acids formed in the atmosphere fall to the ground mixed with rain, snow, fog, or hail. Dry deposition is another form of acid deposit. Sorry, this word just bothered me. Deposition. And this is when gases or dust particles become acidic. Both wet and dry deposition can be carried by the wind, sometimes for very long distances. Acid deposition in wet and dry forms falls on buildings, cars, and trees and can make lakes acidic. Acidic deposition is dry form, can be inhaled by people, and can cause health problems in some people. So there's two different kinds of acidification: episodic acidification and chronic acidification. So episodic acidification involves short, intense periods of acid precipitation. So examples are winter snow melts or heavy rains, where things happen really, really quickly within context of the weather, and are going to have a big influx of acid precipitation in that moment. Chronic acidification refers to aquatic and terrestrial ecosystems that have lost their ability to neutralize acid precipitation. So this means that these areas have had such an impact, have been impacted so much by acid precipitation that they're unable to fight against them or survive. Like there's nothing they can do. So what are the impacts on terrestrial ecosystems? So many ways that the soils have changed is really where this comes in play. So number one, it reduces the amount of basic nutrients like calcium and magnesium in the soil. Trees get their nutrients from these trees get their nutrition from these nutrients that have dissolved from rocks. Acid precipitation adds hydrogen ions to the soil, and the hydrogen ions displace basic nutrients like calcium and magnesium. As forest soil loses basic nutrients, trees stop growing. They also become more sensitive to insects, diseases, and drought. As a result, forests die. So that introduction of the acidity into the soil strips them of the nutrients that forests need. So the second way that the soils change, acid precipitation increases the level of heavy metals like aluminum in soils. So aluminum is naturally bound to soil particles, and acid precipitation reacts with soil particles to release aluminum from soils. Then aluminum releases from soils moves into soil water, which passes on to vegetation, lakes, and streams. High concentrations of aluminum in soils can be toxic to plants, fish, birds, and other organisms like earthworms. It can stunt the growth of tree roots and reduce the number of microorganisms like soil bacteria that add nutrients to the soil by decomposing dead and decaying leaves. Then the third way that soil is changed, acid precipitation increases the amount of sulfur and nitrogen in soils. Increased amounts of nitrogen in forest soils may at first encourage forest growth. However, as more and more nitrogen is added to soils, levels rise above what forests can use and keep. Excess nitrogen then leaches into surface water, such as lakes and streams. As this water moves through the environment, it can affect nearby soil and plants. So then how is aquatic ecosystems impacted by acidic precipitation? The ecological effects of acid rain are most clearly seen in aquatic environments, such as streams, lakes, and marshes, where it can be harmful to fish and other wildlife. As it flows through the soil, acidic rainwater can leach aluminum from soil, clay particles, and then flow into streams and lakes. The more the more acid that is introduced to the ecosystem, the more aluminum is released. Some types of plants and animals are able to tolerate acidic waters and moderate amounts of aluminum. However, others are acid sensitive and will be lost as the pH declines. Generally, the young of most species are more sensitive to the environmental conditions than adults. So that means that even if they are animals that can survive in more acidic environments, their young may not, which means that they will die, and then there will not be an older generation to continue to populate and reproduce. At a pH 5, most fish eggs cannot hatch. At lower pH levels, some adult fish die. Most acidic lakes have no fish. Even if a species of fish or animal can tolerate moderate acidic waters, the animals or plants it eats might not. For example, frogs have a critical pH around 4, but the mayflies they eat are more sensitive and may not survive pH below 5.5. So then if all the mayflies die, then the frogs, even though they can survive in the acidic water, cannot survive because they don't have any food. So here is a image that shows the critical level of aquatic organisms. So that just means, so this figure illustrates the pH level at which key organisms may be lost as the environment becomes more acidic. Not all fish, shellfish, or insects that they eat can tolerate the same amount of acid. So remember, rain is already about 5.4, right? So all of these ones that are above, so snails, clams are at 6, bass at 5.5, crayfish, mayfly all at 5.5, trout, salamanders at 5, perch and frogs, perch at 4.5 and frogs at 4. So if we're adding more and more acid into our precipitation, and that's adding into our aquatic environments, then the pH level of the water is going to be lower and lower and lower, and less of these animals can survive. So how is there going to be these ecosystems? How do they recover? So countries like Canada, the United States have made laws to reduce the amount of sulfur dioxide and nitrous oxide being released into the air. However, factories are still releasing these pollutants. Pollutants released in the air years ago are still affecting ecosystems in negative ways. Over time, the chemical conditions of soil and surface waters will improve. After soils and waters improve, plants and animals populations can slowly recover. Recovery times depend on how much damage has been done to different types of plants and animals in the food chain. Recovery times are also different for different types. For example, it can take decades for forests to recover from the effects of acid precipitation. So this really depends on the situation. And as we continue to add, it's not like we stop. It's not like we have stopped acid precipitation and then things can recover. We're continuing. Acid precipitation continues to exist and be a threat to these environments. So now you can do the key questions on page 48, the check your understanding questions 1 and 2, where you're talking about acidification and how soil change because of acid precipitation. All right, so that covers how human activity affects ecosystems. Obviously, there are other ways that human activity affects ecosystems. This was just a focus on two of the impacts that we have that have a huge impact, to just sort of focus it and really learn about those two areas. So remember, we talked about oil spills, where kelp and seagrasses die while some algae thrive and become excessive, and then animals also die in many ways we talked about. Similarly, forest and land animals die due to pipeline leaks. We talked about acid precipitation. The increase of some nutrients and the decrease of other nutrients means trees and other plants do not have what they need to grow strong. And lower pH levels in water are toxic to some animals, dramatically changing food chains. Recovery can take years to decades, and we need development of laws and implementation of laws in order to actually make a change. We can't just talk about it in general. We need to really make concrete action to make change. So hopefully you now know the impacts of oil spills on both aquatic and terrestrial ecosystems. You know the impacts of acid precipitation on aquatic and terrestrial ecosystems, and you can explain how ecosystems can recover from these human impacts, as well as how likely they are to recover or how long it might take. Now you're able to do the review questions on page 51, questions 1 through 12, which again, I'll talk about the various oil spill, including the Exxon Valdez, which we talked about briefly, but also talks more about in your booklet, and acid precipitation, the impacts, and how change can happen. So that covers today's lesson number 6 in your booklet, which I can't quite remember if that wraps up unit 2 or not. Sorry, my brain is foggy. I think that there's one more lesson in unit 2. If you have any questions, please reach out and contact me at 807-737-1488, extension 2209, or toll free 1-800-667-3703. The best time to call me is between 8 a.m. and 2 p.m., as that's when I'm in the office, though I teach from 9 until 11, so I'm not available then. Email is more reliable to get a hold of me, but that is through bronwyn.slate@nnec.on.ca. My name is spelled BRONWYN.SLATE. Connecting me through Facebook and Facebook Messenger is also an excellent way to get a hold of me, where my name is B Slate Wahsa. And remember, all of our lessons are up on YouTube at B Slate Wahsa channel on YouTube, and under the playlist SVN3E, our course code. Thank you so much for joining me. I hope you have a lovely day, and good luck with answering these questions. Which